Hi, this is Dana with GMAT Ninja, and today I'm going to be talking through GRE ratios and percentage questions. So who is this video for? Well, it's for you if these kinds of questions throw you into a spin. If you see that word ratio or you see that percent sign and you kind of don't know where to go with it, this is a great video in terms of getting that initial setup from the page into what you're actually going to be doing with your algebraic expression. And another sort of red flag that might be useful here is if you find yourself overusing your calculator on questions like this, then this video might really help you. That's not to say that the calculator is never useful, right? Sometimes it is really nice to pull out your calculator. But what we see is that sometimes students pull the calculator up because they don't know how to do the setup, and it's more comfortable just to start kind of punching in numbers. So if that sounds like you, then this will be a useful video to learn what to do before you decide whether you even need the calculator in the first place. In terms of what we'll cover, we will start with ratios questions and then we'll go into percents questions. And for both of those, what we're primarily interested in is that flexible, accurate, efficient setup of the question. In other words, you've got all that stuff on the screen. How are you going to translate that into a workable algebraic expression? After we do our ratios questions, and more specifically on percent stuff, we'll first learn the difference between percent of and percent increase or decrease. Those are two very different things when it comes to how to set up your algebra. We'll also go a little bit into simple interest, and then talk about what to do when you've got repeated percent changes within one problem. In terms of difficulty level, this is going to be an easy to medium sort of video, so this is really about the fundamentals of how to get your problems set up in the best way possible. Now, this setup is going to be very helpful for those harder questions as well. It's just that we want to focus right now on getting those fundamentals really, really strong for ratios and for percents. So with that, we will go ahead and start with some ratios questions. I'll pop one up here on the board, and then we will talk about it in a couple minutes. All right. If you didn't have enough time to solve that through, then you can feel free to go back and pause on that screen for as long as you need. But let's go ahead and talk through the question. So here we've got a ratio question, and we're told that in a certain orchestra, the ratio of men to women is 3 to 7. And then the question asks, if there are 210 women, how many men are there? So first thing to notice about this is the word ratio. And what ratio means is just fraction. So we're talking about the proportion of men in comparison to some number of women. And here we're told that that proportion, right, the number of men compared to the number of women is equal to 3 to 7. Now, we don't know the actual number of men or women, right? If you disregard the second piece of the problem, all we know is that at the end of the day, it always works out to be this proportion. But then, sure enough, we are told the number of women in this actual orchestra, which seems like a very large orchestra. I'm not sure how big a normal orchestra is, but it's a lot. So if we've got 210 women, we can just go ahead and replace our W with that 210. So we've got men to 210, right? Some amount of men compared to 210 women is equal to 3 compared to 7. And from there, pretty simple, just to do this algebra, we'll go ahead and cross multiply. So we get 7m is equal to 3 times 210. Now, you don't really want to do this multiplication because right away I'm going to go ahead and divide out this 7 and just be left with m on one side. And of course, if I do it over there, I have to do it over here. And what I'm looking for is stuff that will cancel. So if I don't have to do this multiplication because I'm going to cancel it out anyway, great, right? Keeps my numbers smaller. I'm less likely to make a mistake. So 210, I would rewrite as 21 times 10, and you can see really clearly that we've got a 7 on the top and on the bottom. So let's rewrite this 21 as 7 times 3. We can get rid of our 7s, and what we're left with on the top is 3 times 3 times 10. And nothing is left on the bottom, so that gives us 90. So we've got our number of men is equal to 90, and that is our final answer. Now, this is a totally viable way of solving the question, but I want to give you another thing to think about that will come in handy for more difficult ratios questions, which is to think of the concept of a multiplier. So if you're thinking about this orchestra, let's say it's a tiny orchestra and the actual number of men is just 3, and the actual number of women then would have to be 7. Let's say the orchestra doubles in size, right? So we double our number of men. Well, we'd have to also double our number of women. Or let's say it's triple from its initial state, right? We'd have 9 men, and then again, we'd have to triple our women as well, and we'd have 21 women. Now, what's happening here is that if I take 3 and 7, well, both of those numbers, let's just say we're multiplying them by 1. Then if I multiply one piece of my ratio by 2, I also have to multiply my other one by 2, right? So both of these are multiplied by 2. This one is multiplied by 3. Guess what? This one also has to be multiplied by 3. So if I take my initial number, right, and I multiply it by x, then I know that I also have to multiply my other bit by x. So if I figure out my multiplier on one of these things, then I know it's the exact same number on the other piece of the ratio. Where this comes in handy is I'm given the number of women, and I've also got that represented here as 7x in my ratio. So I can just say that 7x is equal to 210. We'll go ahead and divide out the 7 on both sides, and we are left with x is equal to 30. Now, we're not at the end of the road. We're not just solving for x. We're solving for the number of men. In other words, we're solving for 3x. So if x is 30, then 3x is 3 times 30, which is 90. So you end up exactly at the same spot that you did solving it the other way. Now, the reason why I much, much prefer this way where you're using the multiplier is that you are down to just one variable. So here you've got 2 variables. Yeah, sure, one of them pretty quickly goes away. But in the next question, and in a lot of ratios questions that you see, you don't want to be dealing with multiple different variables when you could just deal with one, that multiplier that's consistent across. Especially if you imagine if you've got a 3 or 4 part ratio, man, you don't want to have 3 or 4 variables. So this multiplier concept is super, super powerful. Think through the next one. Try to use this concept as you saw through the question that I'm about to put on the screen, and then we will talk it through after. All right, let's go ahead and talk through it. So here we've got another ratios question, and we are told that a clothing store sells items in small, medium, and large, and those items are sold in a ratio of 5 small to 7 medium to 10 large. So our task is to figure out which of these can individually tell us the number of small items sold. Now, I've got this ratio, so what I'm going to do is immediately say, I know that there is a single multiplier that will work across the board here, right? So whatever I multiply this 5 by, I'm going to have to multiply x by the same thing. I'm going to have to, multiply 7 by the same thing and 10 by the same thing. So we'll just go ahead and call that variable x. And I don't know what x is because I don't know how many things are sold yet, but I do know that it's going to be the same regardless of which piece of the ratio that I'm dealing with. Now, we're specifically asked about the number of small items sold. So what I'm looking for is, where is that represented up here in my ratio? Well, that is this 5x. So really what this question is asking is, what does 5x equal? Now, if I just figure out what x is, then I'll be able to solve for 5x. So that's a really good thought to have in mind, that if I solve for x, then we're good to go. Let's go ahead and assess these one by one. In the first one, we're told that there are 110 items total. So my thought is, how do I translate this ratio into this total number of items? Well, 5x is going to be my number of small items, 7x is going to be my number of medium, and 10x is going to be my number of large. So if I just add all those up, then I'll have my total number of things that were sold. So let's just do that. We've got 5x plus 7x plus 10x. And then we're told that that all adds up to 110 items at the end of the day. Now, just solve this like you'd solve any other algebraic equation. And here, just adding these up, we get 22x is equal to 110. Divide both sides by 22. I see that they've got an 11 in common, so I'm going to go ahead and take out that 11 on the top and the bottom, and then just do this simple division, get rid of that 2. And I find out that x is equal to 5. So if x is equal to 5, then 5x is going to be just 5 times 5, which is 25. So this is my number of small items that were sold. So one on its own can figure out that information, so that would be good to go. That would be sufficient. Let's look at statement 2. We learned that the number of mediums that were sold is 35. Now, again, up here, I'm looking for my number of mediums. Here, I've got it represented as 7x, and statement 2 tells me that 7x is equal to 35. This seems simple enough. We'll just divide out the 7. And again, we will find that x is equal to 5, puts us in the exact same spot as here. 5x is going to be 25, and that's my number of small items sold. So sure enough, 2 is also sufficient on its own. And finally, we have this last one. There are 15 more large than medium items. I think that the language here is slightly trickier than on the first two, so let's talk about it step by step. We know that we're talking about medium items. We know that we're talking about large items. Let's go ahead and represent those just like they're represented up here. So my number of large is 10x. My number of medium is going to be 7x. And then I've got this 15, right? 15 more. So I'm adding 15 to something here. And what this is telling me is that my number of medium is a little bit smaller than my number of large, right? My number of large is 15 more than my number of medium. So that means I have to take my 7x and add the 15 to it, right? So take my number of medium, add 15, and then I'll suddenly end up with my number of large. This logically checks out if you think about it, because x is going to be a positive number. Don't know what it is right off the bat, but it's going to be a positive number, so 10x is going to be the bigger number than 7x. So I'm taking my 7x, my smaller of the two, and I'm adding something to it, and then it, at the end of the day, results in my bigger number, right? It would not make sense to do the opposite, have my big number, and then add more on top, and somehow that's supposed to equal the smaller number. So logically, it makes sense that it would be set up this way. And then again, we've just got one equation, one variable. Let's go ahead and subtract 7x. You get 3x is equal to 15. And divide out your 3, we get x equals 5. And again, 5x is equal to 25. So statement 3 alone, also sufficient to solve for my number of small items, and we will go with that. So that concludes our ratios questions for today. The two key takeaways here are, first, that ratios are fractions. That can be really, really powerful if you're trying to create an algebraic expression. And then the second tool is this multiplier tool, right? Where you can just use one variable that will be consistent across each piece of your ratio. And that can really simplify your life when you're dealing with more complex problems where you don't want millions of variables flying around, you just want the one. I hope that's been helpful on the ratios. We'll go ahead and switch gears now and talk about percents. So I'll throw the first percent question up on the board and give you some time to work through it. All right, let's go ahead and talk about this. So, very first punchlines when it comes to percents is that you want to translate this kind of gobbledygook, right? These words and these kind of symbols and stuff into really nice, clean algebra. And you want to do that translation as directly as possible. So, we're just going to step by step go through the translation of how to set up this question. And we'll start with this little bit here. We know that P is 60% of R. So what I'm going to do is just word by word go through and translate each piece of that. And what we get is P turns to equals 60%. If you think about the word percent, well, per just means per, right? Over. And then cent means 100, right? So if you know any Romance languages, cent is going to be that root word for 100. So what we get here is over 100. So 60% translates really nicely to 60 over 100. And then we get of, which translates to multiplied by r. So P equals 60 over 100 times r, pretty simple and very checkable if you just do it word by word across the page, sets up beautifully into your equation. Now, let's do the same thing for the next little bit. We get that Q is 25% less than r. Start out the same way, Q is, so Q equals 25% less than. Now, you can write that out literally if you want, but I think there's an easier way to think about it, which is if you've got the whole of R, right, or the whole of anything, right, and then you take away 25%, well, what are you left with? You're left with 75% of that thing, right? So if you had $100, take away 25, you've got $75 left. So I think that thinking about that, what do I have left, is much easier than doing the subtraction. So I just go ahead and say 25% less than means the same as I've got 75% left. So 75% of multiplied by r. So we've got these two nice equations from those two little bits at the beginning, and let's do the same thing for this last bit of the question. And what the question is asking is P is what percentage of Q? So same deal, P equals what percentage? Obviously, we don't know what goes on the top of that over 100, so I'm just going to go ahead and throw in another variable. What percentage I'm going to say is y over 100, and then of Q times Q. And what we're solving for here is that what, right? What percentage is it? In other words, our y, right? Now, I don't really want to deal with this extra variable for very long because we're introducing this new one. We've already got a ton of other variables going around. So let's go ahead and solve for y here so that we know what we're looking for in terms of p and q. So we've got it multiplied by q, so let's go ahead and divide that q to the other side. So we get p over q is equal to y over 100. And then we'll go ahead and multiply both sides by 100 so that we get y all alone. And we get 100p divided by q, right, is equal to y. And so this is really what our question is asking us to find, right? 100p divided by q. So because we know we're looking for p's and q's, and up here with our two given equations, we've got this r involved, that gives us the hint to go ahead and get rid of our r's, right? So I'm looking for the easiest possible way to just be dealing with p's and q's, not be dealing with r's. And what I have decided to do is just solve each of these for r, so r is alone on one side, and then I can set those two things equal to one another. So before I start messing with stuff, I'm just going to make these numbers smaller and easier to work with. 60 over 100, both of those are divisible by 20, so let's go ahead and take a 20 out. We get 3 over 5. So we're left with p is equal to 3 over 5r. And then again, trying to get r all alone on one side of the equation, we'll multiply both sides by 5 over 3, and we are left with r is equal to, 5 over 3p. And let's go ahead and do the same thing over here. Of course, both of these are divisible by 25. Let's go ahead and get that 25 out of there. So we get q is equal to 3 over 4r. And trying to get r on its own, we'll multiply both sides by 4 over 3, and we will get 4 over 3q is equal to r. Now, since both of these things are equal to r, I can set them equal to one another. So I get 5 over 3p is equal to 4 over 3q. That equals kind of gross. And just to make our lives easier, let's go ahead and get rid of that 3. We'll multiply both sides by 3, and we will end up with 5p is equal to 4q. Now, I'm trying to get 100 times p divided by q, so one step in that direction is going to be to divide both sides by q. Cancels on this side. And what I'm left with is 5p over q is equal to 4. Now, I don't want 5p, I want 100p. So how do I get from 5 to 100? I'm going to multiply by 20. So I, of course, have to do that on both sides. And cleaning this up a little bit, we are left with 100p divided by q is equal to 4 times 20, otherwise known as 80. And that is my final answer. Now, the nice thing about setting it up this way, right, where you're already putting that over 100 into your initial equations, is that you are already in percent form. So there's no need to do any additional multiplication or division or anything like that. All you do is slap a percent sign on and your job is done. If you always very consistently set up your equations this way, then you know that you're always good, right? And there's no question later down the road of like, do I have to still manipulate this in any way? So I would definitely recommend putting it in percent form right away. And the overall punchline from this is that direct translation, right? If they give you a word problem that can just be word by word translated into a clean equation, then you want to take that gift and you want to just do that task and then check your work to make sure that you've translated it correctly. All right, we will move on to the next question. So I will throw it up here in a second and then we will talk about it after. All right, let's talk it through. So we've got a somewhat simple problem here, but there are some common mistakes that people make with questions like this, and you've also got some options with how to solve it through. So I want to talk through those options for you. Now, the common mistake is that you see this 20%, and you say, well, wait a minute, if it's 20% up, then surely I discounted by 20%. It's not quite as simple as that. So let's do the math and see, what's really going on here. Now, one way that you could look at this problem is that it is a percent change problem, so you can use your percent change formula. And your percent change formula is just, well, what's the difference between my two different values, two different prices here? And then the important thing is compared to what, right? So you're looking for a percent change from something. And so that is absolutely crucial, is deciding, well, what was my actual baseline price that I'm comparing to? Here, kind of simple to determine that. Other questions can make it a little more tricky, so definitely take your time in deciding what is that baseline that you're comparing to. But here, if we're talking about a percentage discount, well, discount from what? Discount from your regular price. So we've got over our regular price, and then for our difference, just simply subtract your two. So you get your regular price minus your sale price, and then you compare that or divide it by your regular price. Now, let's leave that aside for a second and talk through the translation bit of the actual stem. We know that the regular price of each item is 20% more than the sale price. So regular price is R equals, pretty simple. 20% more than, I'm pretty comfortable using fractions to deal with something like 20%. 20% is just 1/5. So if I've got 20% more than 1, then I maybe started with 5/5. I've got 1 in addition. How many do I have now? 6/5. So R equals 6/5 times my sale price. I'm going to use sale as my variable just because I have terrible handwriting and a 5 and an S kind of look similar when I write them. So you don't have to do that if you've got nice, beautiful handwriting. Now, what we're concerned with is what happened to our regular price, and that's not very apparent from this written out like that. So what I want to do is kind of shift this around so I can really see what happened to my regular price. So I'm going to go ahead and multiply this side by 5/6. And of course, if I do that over here, I have to do it over here. And I end up with 5/6 times my regular price is equal to my sale price. You can actually solve the problem from here without even bothering with your percent change formula. And that's probably what I would do, because what I'm seeing here is, well, I started with 6/6 of my regular price. Now I've only got 5/6 of my regular price. So what happened? What actually changed? Well, I'm missing 1/6. I went down by 1/6, and that is my discount. And then, of course, the other thing that's going on here is that instead of giving you your answer choices in beautiful fraction form, they are in your percent form. And we're trying to approximate as well. So now I have to convert this into a percentage. Probably the easiest way on the GRE, if I'm honest, is if you just pop this in your calculator, it's going to tell you that 1 divided by 6 is just 0.1666 repeating with 7 somewhere in the end. And from there, this is your decimal form, so you can just go ahead and multiply by 100, and you would be left with 16.6666. Here they've rounded it in answer choices to 16.7%, and your job is done. Just to give you some options, 1/6 you can figure out pretty easily by using a fraction that you're much more familiar with, which is 1/3. 1/3 as a percentage is going to be 33⅓%, right? 33.3333 repeating. And 1/6 is just half of 1/3. So all we have to do is divide this by 2, and then we end up where we want to go. Now, to divide this by 2, I would first think about like the easy bit to divide by 2, right? That gets me pretty close, is if I divide 32 by 2, I get 16. So now I've accounted for 32 out of this 33.5. What's left that I haven't divided yet is 1 1/3, right? That's kind of the bit that gets me from 32 to 33 1/3. So we've got 1 1/3, also known as 4/3, that I have not yet divided by 2. This is pretty easy to divide by 2. It's just going to be 2/3. So I end up with 16 2/3%. And you end up exactly where you did before, which that works out when you round it out to 16.7%. Now, if you feel more comfortable using the percent change formula, you can absolutely do that as well. And all we're going to do is substitute some of these variables so that we only have one variable we're dealing with. And I think it's easiest to substitute out the sale. So we'll end up with r minus, and over here we've already figured out that our sale is equal to 5, 6r. So 5 divided by 6 times r, and we're putting that over r. Now, all of my terms have an r, so I can just go ahead and pull out an r, and I'm just left with 1 minus 5 over 6 over 1. Of course, anything just divided by 1 is itself, so don't worry too much about that. And 1 minus 5, 6, same thing as 6, 6 minus 5, 6. I have 1/6, which gets me exactly where I was before. And our percent discount is 16.7%. All right, I'll go ahead and pop the next one up on the board, and then we will talk about it. All right. So my students absolutely hate when they see problems like this, right? There are so many variables flying around, and it feels very intangible, but it's really not that bad, right? So I would definitely recommend sticking with the variables, sticking with the algebra. Don't try to throw random numbers in there to get rid of them. And we'll see exactly how it all works out here. So here we've got the price of a car, and then a bunch of stuff happens to that price of the car, and then at the end of the day, it is equal to P. So we know that at the end of the day, something is equal to P. So let's just go step by step through this and do a translation. So we've got some price of a car, let's call it X. And then that price is raised by a percent. So when I'm thinking about what to multiply X by, well, I know it's going up, right? So I know we have to have something greater than 1 so that my price gets bigger. So let's start with 1. And then on top of my just price that I've already got, I'm putting an additional a percent on top. So it's going to be 1 plus a over 100. Now, this might look a little crazy if you haven't seen it before, but it's just like if you had an actual number in there, right? Let's say we're raising by 5%. Well, you would start out with your 100 out of 100, and then you would add in your 5 out of 100, right? And you'd be left with, 105 out of 100, and you've gone up by 5%. This is the same exact thing, it's just that we don't know what a is, so you have to kind of write it out like this until you know what the value of a is. So then it's discounted by b%, very similar logic, right? If we start with 100% of what we just had, now we are discounting or we're removing b%. So we just subtract 1 minus b out of 100. And then we are raising again by c%, so we just multiply that whole thing by 1 plus c over 100. And finally, we end up with our price p. This looks kind of nasty, but let's see how it all works out when we get to our actual comparison bits. So A is asking us for the value of p given these specific values for a, b, and c. So let's just go ahead and throw those in. We're going to start with x. And if a is 20%, right, I could go ahead and write out 1 plus 20 out of 100, and then I could find that common denominator and do all that work. I don't really feel the need to do that as long as I'm really careful. If I know that a is 20%, I know I'm going up by 1/5. So if I start with 5/5, then I have 6/5 at the end of that transaction, right? Now I'm going down by 1/4. So if I'm going down by 1/4, that means I'm left with 3/4. So I can just write 3 out of 4. And then now I'm going up by 11 and 1/9 out of 100. What a gross number, right? This is just a good one to know. This one equates to 1/9 as a fraction, right? So if you've got 11 and 1/9%, it's going to be 1/9 as a fraction. A way to think that through, if you don't know that off the top of your head, is again to think about 1/3, which you're probably pretty comfortable with. That one is 33 and 1/3%. So how do I get from 1/3 to 1/9? Well, this is just 1/3 of 1/3. So 1/3 times 33 and a third. 1/3 of the 33 part is just going to be 11, and then this 1/3, I need 1/3 of 1/3, and I'm going to be left with 1/9. So much nicer to work with this fraction of 1/9 rather than working with 11 and a ninth divided by 100. So what we will do is just say 1 plus, and then this whole fraction I know is going to be 1/9. So if I start with 9/9, then I end up with 10/9. Now, I know I'm going to want to cancel a bunch of stuff here, but for me, I like to work through the higher level pieces of the problem first and then get into the weeds in the smaller details of the question. So I'm going to go ahead and get my full setup over here, and then I'll go ahead and cancel stuff out. So the value of p, and then we've got all these different numbers, so we start with x again. A is 20, exact same thing that happened over here, 6/5. B is 40, so I'm going down by 40%, so I'm left with 60%. So that is 3/5. And then C is 33 and a third, so I'm going up by 1/3. If I start with 3/3, go up by 1, now I've got 4/3. And with that, now I'm going to go ahead and do my canceling on both of these and see which one of these might be bigger. We'll go ahead and start with this 5 and this 10. That cancels out to a 2. This 9 and this 3, that cancels out to a 3 down there. We've got a 3 and a 6, that cancels out to 2. I've got 2, I've got 2, I've got 4. Those all cancel out. And at the end of the day, I am just left with x, which is kind of nice. Let's do some canceling over here. We have a 3 and a 3, and then does not look like we've got really anything else that can cancel, so I'm just going to multiply across the top and the bottom. We are left with 6 times 4, 24 over 5 times 5, 25x. So I've got x compared to 24 out of 25x. We know that x is going to be some positive value, right, because we're dealing with prices, so they're not going to sell you a car for negative dollars. So a full x is going to be more than this not quite full x, which means that a is going to be my bigger of my two quantities. All right, so punchlines here are that the variables are really not that bad, and it can really help you then translate into your setup down here. I would not go ahead and punch in numbers and stuff until you actually know what those numbers are. And then the other thing is that you want to deal with fractions rather than dealing with these kind of gross numbers. So it's good to know some common translations, or if you've got some really well-known ones, then you can sort of back your way into some of these other lesser-known fractions. All right, I'll go ahead and put the next one up on the board, and then we'll talk it through. Okay, so we've got a pretty simple percent change formula question here, but people mess up with actually setting up that percent formula equation, so let's just go ahead and be careful in setting that up. Now, your percent change is always going to be some difference in values, but it's not just the difference in those values. You have to then compare it to something, right? So it's some percentage change from some baseline value. And that is the thing that tends to be tricky, right? Is what is that baseline value that you're comparing your difference to? So you just want to take an extra second to make sure that you're setting that up properly, that it all makes sense. For this particular question, our baseline value is going to be determined by how the question's asked, right? So it says, what was the percentage change in the number of members in 2021? In other words, we started with a certain number, we ended with a certain number. In comparison to that starting number, what happened, right? How much, what percent did we change by? So we're comparing to our beginning number. And then to get the difference, we can just subtract one value from the other. Let's go ahead and say that our ending value minus our beginning value will give us that difference. And then we're comparing that change to our beginning value. From there, all you do is just plug in your numbers from the question. We know that it had 14,500 in the beginning. So that goes here and here. And then at the end, we had 15,660 members, so that goes there. Now, on the GRE, this is probably the point at which I would take out my calculator. Not too bad to do this math, but probably a little bit quicker if you just punch it in your calculator. If you go ahead and do that, you're just going to end up with 1,160 on top and 14,500 on the bottom. And then again, I would just do the division in the calculator, and I would end up with 0.08. And then this is in decimal form, so to turn that into our percent, all we have to do is multiply by 100, and we end up with 8%, and that is our answer, C. Key thing on the percent change formula is just what are you comparing to, right? Because you can ask this question in a different way, and suddenly the baseline is actually the later date. So just be really careful to know what is my baseline that I'm comparing to, and then you won't go wrong on your percent change formula. All right, let's go ahead and do the next one. Okay, we've got a interest question here, so let's go ahead and talk it through. This investor is investing in a place where they give him simple annual interest, so I think it's worth talking through what that means before we dive too far into this question. So let's say, different problem that you have $1,000 and you're putting that into an account, and let's say that account has 10% simple annual interest. What that means is that the end of year one rolls around, and guess what? By then, you have earned 10% of your initial $1,000. So you have earned $100 in interest, and overall you are left with $1,100 in the account. Now, the end of year 2 rolls around, right? And even though you had $1,100 in your account that entire year, guess what? You don't earn interest on all of that money. For simple interest, you only earn interest on the stuff that was in your account at the very, very get-go, your principal. So year 2, guess what? You earn the same exact 10% of the same exact $1,000, and you earn another 100, and you end up with 1,200 in your account, right? And then, etc. It would be the same exact thing. Every single year, you're only earning 10% interest on this initial $1,000. That's different than compound interest, which you might be more familiar with, actually, because that's what is more commonly used. Compound interest, you do earn extra money on all this interest you earn, right? So it's going to compound on itself. It's a little bit of a better deal if you are looking for an investment. So this person may want to put his money elsewhere. But simple interest, you're only earning interest on the initial principal that you put into the account. Now let's talk about this exact scenario. We have 2 different accounts, and I think it makes sense just to talk about that first account for a second here. So the first account, he is putting $4,000 into it, and then he is earning 12% annual interest, with a very, very key word being that annual interest rate. And then out of that first account, he's taking all his money at the 6-month mark, right? So sadly, at that 6-month mark, he has not earned his full 12% annual interest because he has not left it in for a full year. And because 6 months is half of a year, we know that he earns half of that 12%. So if we're talking about the interest in this account, then what happens is that he started with his $4,000 and then he earned 6% interest on that $400. 6% translates to 6 over 100. Now there's of course stuff that we can simplify here, but let's go ahead and talk about the other account first and then we'll put it all together. So his second account, and again, just talking the interest that he's earning, he put $6,000 into that account, and then he takes it all out after 1 year. So congratulations, he's making his full annual interest amount. What is that amount? It is just X%, so we're not quite sure. But we can just write it as he's put his $6,000 in there, and then he earns some percent of that $6,000 as interest. The end of this question tells us that he makes the same amount of interest from both accounts. In other words, my interest from my first account is equal to my interest from my second account. Gives us a nice, simple, beautiful equation, just one variable to solve for, and that is going to be our answer. So at this point, now that we've got the full setup, this is when I would start canceling and simplifying. Let's go ahead and get rid of some zeros. 2 zeros on the bottom, 2 on top, 2 on the bottom, 2 on top. We are left with 40 times 6 is equal to 60x. We'll divide by 60 on both sides. Those cancel nicely. And from here, again, just still canceling. We'll cancel out a 0, top and bottom. We'll cancel out a 6, top and bottom. And we are just left with x is equal to 4. So our final answer is A. So for simple interest, main thing to know is just that you're not making any more money each year after year. You're just making the same amount every single time because you're only earning interest on your initial principal that you threw into the account. And then from there, you can answer some pretty flexible questions about simple interest. It doesn't seem that compound interest shows up on the GRE. If you find any official questions that talk about compound interest for the GRE, definitely throw it in the comments and we will address it in another video. We'll go ahead and do 1 or 2 more questions. I will pop that up on the board right now. All right, let's go ahead and talk it through. So a lot of our students hate these kinds of problems. And the reason why they dislike them is because it's kind of difficult to interpret what's going on and to do that translation step into your algebra. And then it's also difficult to know what the heck is happening. What are you actually solving for here? So we'll just go step by step and talk about what all of this means. So first of all, we learned that positive integer m is inversely proportional to the square of the positive integer n. Ugh, yikes. There's a couple things going on here, right? First is this word inversely. What inversely means is that as one of these things is going up, the other one is going down. And how that works out mathematically is that you're going to have one of your things, and then that's going to be equivalent to something with the other thing in the bottom of a fraction, right? So m is, right, inversely proportional to the square of n. So we can write that as 1 over n squared. Now, it doesn't tell us that these things are equal to one another, though. It tells us that they're proportional to one another. So we can't just say that these are simply equal to one another, but we do know that there is this relationship that always holds true. To represent the fact that it's proportional and not necessarily equal, we can just throw some constant k in there, right? So it might be that these exact values don't work out, but always it's going to work out when you throw in your k. And this just represents that, hey, it's not equal, it's proportional kind of deal. Now, some stuff is going to happen to m, and then we're going to figure out what happens later, but I want to focus first on what is this question actually asking us to find, because it can get really, really squirrely if you don't have your head wrapped around that. So we're asked the value of n decreases by what percent? And I'm going to really carefully write that out for myself before I get too far here. So n goes down by how much? Is what I'm going to write for myself as just a really good reminder to make sure that I'm solving for the correct thing here. Now, we know that the value of n increases by 125%. So we're going to go ahead and get another formula written up here. And then our question is, well, what happens to my n? So let's represent this, right? M increases by 125%, so it goes up by 5/4. Now, be careful. A lot of people see that and they just write 5/4 m. But it's not that we're timesing m by 5/4, it's that we're going up by 5/4. So we start with a full m, we start with 4/4, and then we go up by 5/4. So we are actually left with 9/4 m when we increase by 125%. And then the question is, the value of n decreases by what percent? Well, so what we're really asking here is what happens to my n? Now, the n is squared. So whatever happens to the n is also going to be squared, right? So you can just think of it as like, well, to make this still hold true, I need to do something to my n to compensate for this increase in m. And then that whole thing is going to be squared. And my question is like, hey, wait a minute, like what happened here to n? So at the end of the day, we're interested in solving for x. That doesn't mean x is going to be our final answer because this is our final answer, but we'll get there as we solve through. So to make this a little bit simpler, let's go ahead and distribute out this square. So that's going to be equal to k times 1 over x squared times n squared. Now we've got like a whole bunch of pretty nasty variables here. We want to start eliminating variables. So I've got 9/4 m on one side, I've got this mess on the other side. How can I eliminate some of these variables? Well, I can rewrite m to some of this other stuff, and then I know that a bunch of things are going to cancel out, which is exactly what I want. So if m is k times 1 over n squared, then I'm just going to substitute that in. So 9/4 times k times 1 over n squared is equal to k times 1 over x squared times n squared. And thankfully, now a lot of our stuff cancels out. We don't have to deal with so many variables. Our k's just cancel out on both sides. We divide it out. We can multiply both sides by n squared, and those cancel out really nicely. And we are left with 9/4 is equal to 1 over x squared. And then if you want to, you can go ahead and cross multiply. So we get 9x squared is equal to 4. Divide both sides by 9. X squared is equal to 4 over 9. And then we can just square root this, and we will get that x is equal to 2/3. So we have solved for x, which is very nice. We know exactly what happens to n when you increase m by 125%. Then this n, you are multiplying it by x, which is 2/3. However, that's not what we're asking, right? We are not asking at the end of the day, hey, what did I multiply n by? We're asking how much did n go down by? So if we start with just a normal n, right, 1/1 n, and then we end with 2/3 n, well, what happened? What changed? We went down by 1/3. And our answers here are given in percent, so we can rewrite that as we went down by 33 1/3%. So our final answer is B. So when it comes to questions like this, yes, there are going to be a lot of variables flying around, but you can solve it through just using your normal algebra that you would use anywhere else. The special things when it comes to these proportion questions are, account for this. This k might become relevant in some other questions. Here, just cancel it out anyway. But it's good to keep track of the fact that these things aren't necessarily equal. They're just proportional. And then, of course, the other important word here is this word inversely. If it says inversely, then you know it's 1/. If it says directly proportional, then you wouldn't do the 1/. You would just say that those two things are proportional directly to one another. Then from there, you know that one side of your equation is changing, and then the question is what happens to the other side? What happens to the other variable? And that's when you just go ahead and throw in the thing that you're solving for and work just like you would through any other algebraic problem. All right, I hope that was helpful, and let's go ahead and do one last question, and then we will call it good on the percents video. All right, let's go ahead and talk through this last problem. We've got that last year, Fatima spent $9,400 eating out. If this figure is between 1/7 and 16 2/3% of her total income, which could have been her total income? Now, right off the bat, I see this 16 2/3%, and that's a pretty gross number. So I'm going to translate that into a fraction. And I know that 16 2/3% is the same as 1/6. As a fraction, much, much nicer to work with 1/6. So we will work with that. So this is telling us that $9,400 is between 1/7 and 1/6 of her total income. If it's near that 1/7 mark, what that's telling us is that that $9,400 is taking out a smaller chunk of her overall income, right? So her income has to be higher for this to be 1/7 of her income than it would be for it to be 1/6 of her income. And the reason why that's important is because to solve this question, my idea here is to max min, right? What is the absolute maximum that her salary could be? And then what is the absolute floor, the minimum that her salary could be? And then we're looking for the options that fit within that range. And it's also good to note that this is one of those questions with those boxes, which means that multiple of these answer choices could be correct. So let's go ahead and figure out her maximum salary and her minimum salary. So for her maximum, we know that 9,400 is equal to 1/7 of whatever that income is. And then for her minimum, we know that 9,400 is equal to 1/6 of whatever that income is. If we solve for the income here, then we would get 7 times 9,400. Here we would get 6 times 9,400. This is a great time to whip out your calculator if you're into it on the GRE, so I would go ahead and do that, and if you do so, you will find that her maximum salary is $65,800, and then her minimum salary is $56,400. And just like we planned, this gives us a nice range, and we're looking for numbers that fall within that range so that we can say that, yep, this could be the amount of her full income. So minimum is 56,400, so 54,000 below that. 56,000 and just $40 is below our minimum, so that is out. 57,000 and change, yep, that falls within our range that we want. 61,000, that falls within our range. 64,000, that falls within our range. 66,000, too high, it's above our maximum, so does not fall within our range. So with that, we know that it's these 3 answer choices that are the correct ones, and we have solved our final problem. So I hope that this has been a useful video for you. I hope you got some good takeaways in terms of ratios and percents problems. And thank you so much for watching, and see you at the next one. Bye.